Everyone, my name is Joris Peels, and this is another edition of 3D Printing News Unpeeled. So today we've got a couple of little news items with you for you, courtesy of 3dprint.com, and one of them concerns Bondtech. So Bondtech is a manufacturer of like hotends, extruders, sensors, and stuff like that, and they provide aftermarket accessories to help you improve your 3D printer. Really good products, by the way. Now, they had a YouTuber called MirageC who made a video looking at the main gear of the main shaft assembly of, well, not only just one extruder, but of a whole bunch of them. That same shaft assembly, that same kind of gear, powers a whole bunch of Bondtech products. And he showed that shaft had run out, and there was a wobble during the rotation. And this, of course, would mean that you have very uneven, very, not very accurate extrusion. Now, this potentially is very, very bad news because it could be like a lot of reputational. It could, have a lot of reputational issues for Bondtech. Now, a lot of companies may have tried to undercut what Marcia was saying, maybe try to make that person look bad or ignore it, hope it goes away. But the Bondtech team met with the MirageC, met with other members of the community, and then used this to improve the main gear. They made a better design. They made some better procedures or something that were a bit unclear. They improved their tolerances overall, which should make this run-out problem, this wobbliness problem go away. They then used some kind of new thermoplastic material, have a thermoplastic gear. Could be this Igus Iguldur stuff they like, or it could be something like polyamide or POM, or it's also called acetal, something like that. It looks a little bit like POM, I think, I don't know, or maybe PA. And they approved the design for this gear, right? And they then got a better gear that works better. Now, this is absolutely fantastic. And this is using user-driven innovation to improve your own products and to work with your community to get a better product for everyone. Now, of course, we saw this a lot years ago. We saw a lot of this happen many years ago when open source companies or companies that were touting this open source innovation were getting a lot of support from their communities. A lot of people were helping them make their products better. And there was a lot of disappointment at the end of this. And now there's a lot of companies that call themselves like manufacturers open source printers, but the printer is kind of, maybe the design is open source, but anything the company makes doesn't actually go back into the community. So this kind of thing is actually really exceedingly rare now. The community doesn't trust the 3D printing companies. 3D printing companies don't, see their community much more as consumers. And so I'm really happy to see this. I'm really kind of like, but it's not only like the romantic in me that's like, oh my God, remember the days when we all worked together on improving the thermistor or whatever, that kind of stuff, right? No, it's also kind of the practical, the business person in me saying, wait a minute. Some companies like Bondtech, for example, or other companies can build communities, can nurture these communities, can be honest and open with them. And in so doing, get a better following, a more informed, more vibrant community that actually works with them to improve their product. So there could, apart from being all open source and doing open source hardware and all this together, we can also get certain companies that commercially can exploit their communities in a way that the communities would like to be exploited, in a way that the community is like, yeah, I'll take my time to do your survey, or I'll take my time to give you feedback, but I'll trust you. Right? Imagine another nozzle company that maybe is less trustworthy, or is less nice, or is less proactive. They may never get this kind of innovation. So there could be a real benefit in channeling this user innovation going forward. I think this is like something that's really hopeful, that gives me a kind of an idea that maybe in the future we would get a little bit more of this. Now, the next thing is, well, something called Freeform Future Corp, or Freeform Future Corporation, I guess. Which is, okay, one of the nuttiest names I've ever seen in 3D printing, and I kind of like it because of that. And it's a company that, after kind of what we've seen Velo do, Seurat, and Vulcan Forms, is kind of really willing to, or wants to fundamentally disrupt powder bed fusion. Now, where Velo 3D is essentially taking the black box that is 3D printing and understanding it much more, what is going on in the melt pool, Velo 3D monitors it more, has software more, and kind of adapts the laser and adapts what's going on in crystallization behavior and what's going on in that magical melt pool, that black hole that is the center of our technology. Velo understands the black hole better, and that's how they deploy their technology better. Seurat is looking at powder bed fusion in a different way. They're saying, no, everybody is working in this little tiny box, and we're going to make the box a lot bigger. And we're going to do area-wide 3D printing, and Vulcan Forms also a similar type of approach. Well, what Freeform is doing is they're going to think completely out of the box, let's say, and they're going to say, no, no, we're going to build a factory. Now, in some sense, Suralt is also building factories, and they're building factories of machines. But what Freeform is doing is they're essentially having a TNO racetrack kind of paradigm or kind of approach to powder bed fusion. Now, if you're not familiar with this, TNO was a Dutch research institute, and a couple of years ago, they developed a racetrack approach where parts move around in a kind of really complicated assembly between certain different steps in a vat polymerization process. Now, this has inspired a lot of people like Inkbit and other people, or just have a similar approach that kind of like says, no, we're not going to do this process in a box anymore. We're going to like do this process. We're going to go outside the box in the sense that we're going to do one step in the box and then one step in other kind of conveyancing. And so Freeform is doing this for powder bed fusion. So what are they essentially doing is they're building an entire factory, and they're going to pass a build chamber underneath the lasers, 18 lasers, right? Which in and of itself is going to be complicated, but these 18 lasers are going to be functioning all the time. Then the build volume will pass through these lasers and then go elsewhere to be finished, or go elsewhere to be recoded. And another build volume will then pass through the lasers. So they're saying, no, no, we're not going to say one machine makes a thing, no, no, or a whole bunch of machines together will make a factory that is going to be efficient. Or what Additive Industries did years ago, they have like a printer that does all this conveyancing in one machine. No, 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 we're going to do it in a much larger space. We're going to do it in a factory. So this is very ambitious. The company so far has raised $45 million from Founders Fund, Threshold Ventures, Valor Equity Partners. 45 million it doesn't seem like it's going to like be anywhere near enough for them to do this. So I hope they manage to raise a lot more money. They also seem to be going on this factory building approach, right? They want to build completely autonomous factories. Now, to give you an idea, like on powder bed fusion, it might be that a third of production costs are actually labor, right? Or depends on the part, but just that's always a kind of rule of thumb, And so that could be a significant savings if they manage to make these things go really autonomously. They also say they're going to be 20 to 50 times faster. And with these they have two conveyor systems and multiple metal plates going through these conveyor systems, and the 18 lasers going at the same time. It does seem to play that they could get a really fast setup here. Now, of course, how accurate it is, how reliable, how repeatable the system is, and how much they know about this laser and what's actually going on, we don't know, right? But the idea, of course, if you look at a powder bed fusion system, it's going to spend most of its time recoding. Most of its time is actually refilling the layer. So you go to the really expensive machine, that's a 3D printing machine. But I always make this joke, it's not actually a 3D printing machine. It's a recoder machine that intermittently 3D prints, right? And by taking this recoding and doing it in a different step, and then focusing on where the hardware is the most expensive and putting stuff under that hardware as fast as possible, that's a really beautiful idea. That is an incredibly beautiful, very, very powerful idea. I love it, right? Now, the other thing is, by then putting this thing in an open kind of environment, moving it all around, I start to worry about fire risk. I start to worry about, are we going to make are we going to have like a chamber that's the size of a factory because I want to build a factory? Or are they going to make they're going to fill that whole place with like an inert gas or something like that? That's going to be expensive. How are they going to keep this stuff from bursting into flames all the time? That's my really big thing. So on the one hand, the idea is oh my God, this is brilliant. We've taken all these recoding machines that are like $1 million to $3 million, and now we're going to make a $20 million machine that's actually going to be a print machine that also recodes in parallel. Beautiful, right? But then also I just worry about the cost of all this conveyancing stuff, the control of these 18 lasers, the computational power needed for this, and also just fire risk is my thing. Now, what they're saying at the moment is that they can build at 5 kilograms an hour, which is, if it's true and then get coherent parts, is very, very impressive. The team itself is a bunch of smattering of SpaceX people. They seem really, really smart, right? Are they hardcore powder 3D printing people like some other people we know? Not really. They're kind of more the application guys and the guys that have really applied this technology through rocket ships and things like this. So if you think about it, if you think of a rocket ship as being an engineering challenge of making a whole bunch of really complicated systems that all go together in a mega complicated system that has to work according to really tight tolerances and work really well in a very critical environment, And you're saying, well, we're going to do that, but it's not going to go to Mars. It's just going to stay in a Fremont warehouse or something. Then it's just a technology integration challenge, right? It's like building a factory, right? It's like we used to have a bunch of guys make cars and beat out the steel by hand, and kind of, and now we're going to automate the system. We're going to put up a kind of a Model Ford kind of assembly line. And then it seems really doable. But then again, it's like, what's stopping someone else from doing exactly the same thing if they just have enough money and understand this is an idea? On the other hand, this does seem like a really daunting challenge, and it does seem like you need a lot of money, especially if they're California-based companies. So salaries are going to be very high, costs are going to be very high. If there were another place, maybe we could do this for twice the amount of money. But in California, 45 million is not a lot of money nowadays. It's a pretty scary thing to say, but it's true. So I love this. The idea is fantastic. The idea that you guys we've got people coming from the client side, the user side to build 3D printers is also, I think, wonderful for us. Will this work? I think the years will tell, and I hope it does, because it'll be really, really very exciting for our business. Anyway, thank you so much for your time. My name is Joris Peels, and this is another edition of 3D Printing News Unpeeled, thanks to 3dprint.com. Have a great day.